So first we need to construct the 6-degree Taylor polynomial P6 of x for function f of x about x0 equals 0, and then we need to approximate the given definite integral. Well, so the Taylor series for f of x is f of x0 plus x minus x0 over 1 integral 1 factorial times f prime of x0 plus x minus x0 squared over 2 factorial times the second derivative of f of x0, and so on. Since in our case x0 equals 0, then this thing becomes the polynomial becomes f of 0 plus x times f prime of 0 plus x squared over 2 times the second derivative of f of 0 plus x cubed over 6 times the third order derivative of f of 0 plus x to the fourth power over 24 times the fourth order derivative of f of 0 plus x to the fifth power over 120 times the fifth order derivative of f of 0 and plus x to the sixth power over 720 times the sixth order derivative of f of 0, and so on. Well, now let's find the derivatives of f of x. So f of x equals sine of x squared. Then f prime of x equals cosine of x squared times 2x. Then the second order derivative of f of x equals 2 times cosine of x squared plus x times sine of x squared times negative 2x. And this equals 2 times cosine of x squared minus 2x squared times sine of x squared. Well, then the third order derivative of f of x equals 2 times negative sine of x squared times 2x minus 4 times x squared times cosine of x squared times 2x plus sine of x squared times 2x. This equals negative 4x times sine of x squared minus 8x cubed times cosine of x squared minus 8x times sine of x squared. Then this equals negative 12x times sine of x squared minus 8x cubed times cosine of x squared. Well, now let's find the fourth order derivative of f of x. It equals negative 12 times sine of x squared plus x times cosine of x squared times 2x minus 8 times cosine of x squared times 3x squared minus x cubed times sine of x squared times 2x. This equals negative 12 sine of x squared minus 24 x squared times cosine of x squared minus 24 x squared times cosine of x squared plus 16 x to the fourth power times sine of x squared. And this equals negative 12 sine of x squared minus 48x squared times cosine of x squared plus 16x to the fourth power times sine of x squared. Well, now let's find the fifth order derivative of f of x. It equals negative 12 times cosine of x squared times 2x minus 48 times cosine of x squared times 2x minus x squared times sine of x squared times 2x and plus 16 times 4x cubed times sine of x squared plus x to the fourth power times cosine of x squared times 2x. Let's simplify. This equals negative 120x times cosine of x squared plus 160 x cubed times sine of x squared plus 32 x to the fifth power times cosine x squared. Well, and finally the sixth order derivative of f of x equals negative 120 times negative 120 times x minus sine of x squared times 2x plus cosine of x squared plus 160 times 3x squared times sine of x squared plus x cubed times cosine of x squared times 2x plus 32 times 5 times x to the fourth power times cosine of x squared minus x to the fifth power times sine of x squared times 2x. Well, now we do the calculations and we get that f of 0 equals 0, f prime of 0 equals 0, the second derivative of f of 0 equals 2 times 1, so it equals 2, the third derivative of f of 0 equals 0, the fourth derivative of f of 0 equals 0, the fifth derivative of f of 0 equals 0, and the sixth derivative of f of 0 equals negative 120. So we get that sine of x squared equals 0 plus x squared over 2 factorial times 2 plus 0 minus 120 times x to the sixth power over 720. When we simplify it, we get that this equals x squared minus x to the sixth power over 6. Then in our case the integral of sine of x squared dx from 0 to 1 equals the integral of x squared dx from 0 to 1 minus 1 over 6 times the integral of x to the sixth power dx from 0 to 1. Then this equals x cubed over 3 from 0 to 1 minus 1 over 6 times x to the seventh power over 7 from 0 to 1. So it equals 1/3 minus 1 over 42. And this equals 13 over 42. So this is our final.